Welcome to our Connecting Networks meeting for this week. It's 11/9/17. So one of the first things we're going to do is discuss some items in NetLabs. When you do a NetLabs reservation, be aware that it takes about 10 minutes for the lab to load. So, and even if you get the main picture, if it's still saying initializing, in that particular respect, it could be that the routers are still booting and being cleaned off. So be aware that if you want to do a lab at 12 noon or you want to do a lab at 1, I would probably go ahead and schedule it for around 30 minutes before. That way you'll have time for it to boot. Like I said, I don't really have control of this router, even though I can see it in the diagram because the router is being cleared by the system and reloaded. Also be aware that, again, anytime you do a reservation, if you do a 2-hour reservation, you only have an hour and 50 minutes. So really when you block off 10 minutes in the beginning for it to boot, and the 10 minutes at the end are used by the system to clear the routers, clear the switches, redo the snapshots. So be aware that you need to give yourself some wiggle room on either side. Now, it is possible in NetLabs to save your configs and come back to them. The only issue is you must have set, when you go to save your configs, it's going to say you must set your console passwords to Cisco and the enable secret must be class. If you do that, okay, so let's say I was working on this lab and this lab's obviously not finished loading yet, but if I was halfway through it and had to leave my office for some reason or had to go somewhere, I can actually go to, as long as I've set all of those, the consoles and the secrets to Cisco and class, I could actually go here and say, all right, I'm doing, what lab am I doing here? I got to figure out which lab it is. 42213. So I can actually go save lab 4.2.2.13 partial and do a save all. And if I have these items configured, those passwords, it will go and save all these configurations for me. You then could come back later, load this same lab and just have it loaded as a default configuration, and then you go into the load tab and you can actually pull your saved labs. Okay. So you would have here, if I did actually save it for that lab 42213 partial, if I do that, it will save that into my load tab, and I will be able to actually pull that up and just click on it, and it would actually load those items directly into my devices. Now be aware, it's going to take a little while, because especially if you click clear current configuration, because it will go through the entire process of clearing the routers, erasing startup config, reloading, and those things. But it is possible to save your configurations halfway through, or if, let's say, you get real close to finishing but don't, you can save them and then come back and just finish the lab by just dumping the configs back in. The other item you can always do is you can always do this. Let's say for some reason I go in the lab and I only get R1 completed. I don't have anything else completed, so I really don't want to go in and save everything. Just go into R1, open it up, do a show run or show start, whatever you want to do, show run, and just save the config file out. So you can just go enable and let's click out here. Do a show run and then just copy it. You got edit copy. You can actually just go in here and do a copy it out, save it to Notepad, and then when you come back, all you got to do is just paste it right back in. So you can actually do it that way too. So it is possible that you can copy the configuration out, put it in a Notepad, save it, and dump it back in. I would only use that, excuse me, I would only use that if I was just trying to save one config, not the entire lab. If you're trying to save the entire lab, use the save functionality that's in the lab. Okay. This is especially true when you get into some of the longer labs. If you ever take CSNA security with me, there are many CSNA security labs. There are 3 routers, 3 switches, an ASA. So there's a lot of work that you have to do, and it's nice to be able to save those things and come back to them if you don't get it all completed. Are there any questions about that, about being able to save your configs and load them?
No, I think one of the other things I was looking at doing, I guess is fine, Kelly, is that I was going to set it where for those larger labs, once we get to those, and then when I take the CCNA security under you, is to go ahead and make it so the login doesn't time out, things like that, login synchronous, and just kind of drop those in on each one of the routers and things like that as I start the configuration.
And you can do that. I mean, if you just had that in a Notepad, you can always just do that. I mean, okay. You can have a basic you know, basic little config that you drop in that's got login synchronous, exec timeout 00, those types of things. So, you know, obviously I never do that in real world, but you could do it, you know, line con 0, login synchronous, and even if you wanted to, you could go ahead and do password Cisco,
Right.
and then log in, and then, you know, take those commands and do a do show run, and all you gotta do is go down here and grab it, and just create yourself a text file, and then you could go into, you know, any of these and open them up and just paste it right in.
Okay.
Yeah. So you could have your base config that you could drop in. The only reason you really can't do it easily for, you know, not all of the labs have R1, R2, R3, or R1 or ISP. So it's better to do a more of a generic. Oops, wrong one. That ain't right. I didn't save it. Let me go back over here. I didn't actually copy it. Helps when you copy it. But you can do that, and then that way it's always in. So you could do your little text file and just drop it in every time. So, and then, of course, again, exec timeout. You can set that to 00 if you don't want it timing out. Again, don't do that in the real world. Yeah, don't do it in the real world. But in the lab world, it's okay. So. Here's something else that's kind of cool. If you ever get in a situation where you mess up your password, you can actually go in and you can tell it to do a password recovery.
Oh, really?
Yeah, and it will set the config register 0x2142.
Yeah.
And then you can go in and actually load, you know, copy, get into privilege mode, copy your config over, and then change your passwords. So that functionality actually exists inside of NetLabs, which is kind of cool. Very neat. You can change exercises too, but that's kind of difficult to do, and I don't really suggest it within a. I don't enable this on all labs. The only reason it's in this lab is because I've got it in a special class that's just for instructors. I don't typically allow this. I'd rather you close it and then bring it back up. That way you've got, I know the lab's been cleared and it's ready for you. Okay. Larry, do you have any questions on those? Sandell, any other questions?
No, you answered a lot because I started running copy and paste in there just to speed up the process.
Yeah, and it does speed it up greatly. And I mean, honestly, that's something the real world students need to be able to do anyway, is create a little text file they just dump the basic config in with. So, all right, I'm going to jump on real quick. Any questions about chapter 1 through 3?
No.
Because I want to kind of jump into 4. Larry, I talked about BGP last week. I don't think I recorded it.
No, you didn't.
Or if I did, I messed it up. So, because I couldn't find the darn thing. But be aware that I have talked about it. If you have any questions, this is very, very basic BGP, so it's not anything that's going to be extremely challenging. This chapter is on access control lists, and it is first begins with a review of what we've already done in routing, switching essentials, talking about how access control lists use wildcard masking. I'm going to be quite honest with you and tell you I'm going to blow through this part, because if you want to review this, please review my routing and switching essentials presentation from yesterday, the 11/8/17 routing switching essentials ITC class. That was everything about basic ACLs. And so I'll just put over here for basic ACL, go to my YouTube channel, which is KCardinal52. Hopefully you've subscribed to it so you get pushed out things that I send. Which, like right now, the only thing I use it for is for the classes. You won't see any dog videos. I don't have a dog anymore, so even though hunting season's in tomorrow or Saturday, I won't have a dog on it. And then review the ITC RSE 11/8/17 presentation. And that will give you that's just a quick overview of how wildcard masks work, what ACLs are for, and how standard IP ACLs work. Okay? So I will do this real quick. Remember, the person sitting in the middle is how we determine inbound and outbound. 1 ACL per protocol, per direction, per port, or per interface is what they say. I say port. We know there are a large number of limitations to what a standard ACL can do, because a standard ACL only filters based upon the source IP address. As we get into TCP and we start looking at port numbers, and we start looking at the ability to do filtering and control in an extended ACL using source ports, destination ports, source protocol, destination protocol, those types of items, we will be able to really be more granular. And I compare a standard ACL to a shotgun. You just kind of get in the ballpark, get in the area, and you're okay with a shotgun. With an extended ACL, it's like a rifle. It's very pinpoint, very accurate. You can drill down and get exactly where you want the control to be and the item you want to either permit or deny. Now, here's a good question for you. What's at the end of every access control list?
You could do one of those for our program review.
Anybody?
An implicit deny.
Implicit deny, correct. So at the very end, even if you had all permit statements, at the end of every ACL, there's an implicit deny. So it will be blocked. So we're going to look at how we filter based upon source and destination IPs, protocol, and ports. Larry, do you have a question? Okay. So first off, here's standard ACLs. Source to only, source destination only. Source only. Where do we put standard ACLs? What is the rule for placement on standard ACLs?
You want those to be close to the
standard ACLs, you put them as close to the destination as possible, because you cannot control what the destination is. You got to put it as close as possible, otherwise you may accidentally filter a destination you don't mean to go to filter. Now, extended ACL, you put them as close to the source as possible. In today's world, most of what we will be doing is extended ACLs, especially if we're using it to actually filter traffic because of the granularity that's allowed. There are numbered and named ACLs. So with numbered ACLs for standard, it's 1 to 99 and 1300 to 1999. For extended, it's 100 to 199 and 2000 to 2699. Don't think you'll have to know the higher numbers on those two, but 1 to 99 and 100 to 199, you need to know that those are the ones for standard and extended IP ACLs. Named ACLs can be written just using a name. They do recommend all caps. It's a company policy. I will say this, just remember, they are case sensitive. And remember that all ACLs have a two-part creation process. You create the ACL, then you apply the ACL to an interface. So if you create the ACL with the name of all capital letters, when you apply it, make sure you use the all capital letters name for your ACL. Otherwise, it won't work. So here we go, extended as close to the source as possible, standard as close to the destination. Now, I'm not a rocket scientist, but in Writing Switching Essentials, they put this same slide and asked you to learn this for standard ACL. They then came back in another chapter and put the same slide and asked you to learn it again. There's also like 2 or 3 activities that ask you to know this. I always tell my students, if you see it once, it's important. If you see it twice, it's really important. If you see it 3 times, probably on the exam. Pretty simple thing that you can teach your students too. All right? I always tell my students too, there's nothing about this stuff that's rocket science. It's just figuring things out and going from there. So this, they show an example of a standard ACL placement where they're going to prevent network from the 10 network from reaching the 30 network. You'll notice you can't put it on the serial interface, because if you had standard ACLs, I'm going to write a standard ACL that blocks traffic from the 10 network. So access list 1, deny 192.168.10.0.000.255. So anything that is from the 10 network, because this is source only. And by the way, this would be on R3 is where I'm going to create it. All right. Now, let me ask you something. I do that, and then I go into int S000, which you could do, sit right there, or at 001, not 000. And I do IP access group 1N. Okay, so it's, remember, it's traffic that's coming in to the person sitting in the router. If I did this, what would be the effect of any traffic trying to get to the 30 network or the 31 network?
They're going to be denied as well. Without you have to permit those networks.
If somebody's speaking, I can't hear you.
Oh, I'm sorry. I was saying they have to be denied. They'll be denied unless you permit them.
Right. Everything would be denied, right?
Yeah.
So in other words, no traffic whatsoever would be allowed in S001 because you've denied the 10 network, but then you also forgot about the implicit deny. So even if you wanted, you know, this is the incorrect place to put it anyway, because it would also block any traffic going from the 10 network to the 31 network, which we didn't ask you to do. We only asked you to block to the 30. But this particular access list would actually block everything because of the implicit deny. What we would have to do is we would need to go to our GI 00 and make it, I can't type again, and make it an outbound on that. And we would also need to add in access with another access control entry, access list 1 permit any. And remember, that's a keyword that replaces this. So I could write it either way. I could put the keyword any, or I could put in quad 0, quad 255, which basically says anything is permitted. If I don't put this, I've actually also blocked 11.0 from getting out this network to the 30, and I've also blocked 31 from getting out. So placement is extremely important, as is the logic behind your access control list. Now, the beauty of access control lists that are extended is that you can set the source and destination. So we don't have to go over to R3. Now, and here's the crazy thing. Here's the bad thing with standard ACLs. Watch this. Hey, y'all, watch this. If this PC1 sends something to PC3 with a standard ACL, not extended, but standard. So let me go back one, sorry. With a standard ACL, that traffic is going to go all the way across these serial links. It's going to be processed by the route plane on R1, R2, and R3, and then it's actually going to get processed by the route plane and start to go out G00, and then it's going to be dropped. So we have wasted the resources on 3 different routers and 2 links. When we go to extended ACLs, we can change that, okay? Because what we can do now is we can, on R1, we can create, in this case, I'm going to block FTP and Telnet, so we can do access list 100, deny. Now, here's where it gets a little funky. What protocol does FTP run on? Man, I just blew it. TCP, right? I gave you that one. So deny TCP from 192.168.10.0, 000.255. Now, what's the destination network? 192.168.30.0, 000.255. And then we want to block FTP. So what are we going to block? EQ, what port?
It'll be 21. You know what's interesting? It's 20 and 21 though, isn't it? But I know most times it's just 21.
Yeah, I usually do both. I usually do 20 and 21. So what I'll do, I know one of them's data and one of them's control. If you block 21, you actually block data, but you have to be careful with passive FTP. But still, I usually do 20 and 21. They also, if you go into EQ question mark, there is a, it actually is listed as FTP-data, FTP-control, I believe it is.
Nice.
Okay. We also want to deny one other thing. We want to deny Telnet. What is it?
23.
23.
23, I'm sorry.
23, yep. Now, we still have to do the following, okay? We still have to do an access list. Now, there's 2 ways we could write this, and this is where Packet Tracer gets a little weird. You can do an access list permit IP any, okay? And if you put this as an inbound on G00 on R1, that would allow any traffic that goes out for anything other than FTP and Telnet to the 30 network, it would work. Okay. Now, some people would argue that you shouldn't do this because it allows if someone was able to spoof for some reason or do something weird. Some people would say, no, I want to write this as 192.168.10.0.000.255 to any. And you know what? They're absolutely correct. And both access control lists would work and would not give you a problem because one is just more specific than the other. And I got to put a permit in there, not a permit. Okay. I was going to tab it out. That's what it was. But you'll notice at this point now, I really don't have to do anything else. I don't have to change anything with as far as the implicit deny because at this point, I've allowed any other host on the 10 network to go to anywhere else with anything IP. And notice how I've changed my protocol. In the beginning, I'm denying specific protocols because that's what's associated with that application. But in the end, I'm permitting IP because I want to allow anything at layer 4. I want to allow any TCP or UDP applications. If I accidentally messed up and did this, okay, what would break for the PCs? What's one application you must have work in order to get out on the internet? DNS would break, right?
Right, DNS, yeah.
DNS would break. DNS is UDP 53 for hosts to go to their DNS servers. So unless there was a local DNS server, you would have, you'd break your network. So if you want to do complete access, you have to do IP, so it supports everything at layer 4. Look how much more specific this is versus standard ACLs. Very specific. You've got your protocol, you've got source, destination, and port. So you can get, that's why you can put it as close to the destination as possible. Now, I didn't use their example of 11, I used 10 just to stay with what we had. But it would work the same way, it'd be inbound. Now, you could also do it here. You could apply it as an outbound on S000. But if you do that, traffic may end up being dropped after it's passed the route plane of R1. And you don't want anything to actually have to go into the route lookup, even though Ceph's extremely fast. You don't want to waste the resources to do a route lookup on a packet that's going to be dropped anyway. So it's best practice to put it as inbound on the gig 00. Does that make sense, Larry Sandella?
Yeah.
Yes, it does.
Okay. Cool. So configure, man, can't talk. All right, standard ACLs. Here they are. Access list number 1 to 99, and then you permit, and then you have to apply it. This is directly out of the other lecture from Routing Switching Essentials. So again, all access list creation is a two-part process. Create it and apply it. You don't apply it, it does not have any effect whatsoever on the router. Named ACLs, you do IP access list either standard or extended. If it is a standard, it'll be config standard NACL. If it's an extended, it'll be config extended NACL, X NACL. So be aware of that. And then you just put in your statements. If it's a standard list, all you have is the source addresses. And if it is an extended, you would have to have deny protocol, source wildcard, destination wildcard, protocol. Show access list, show interface. All this show interface will show you what access list is applied. Show access list will show you all your access lists. All right. So let's go to extended again. Source and destination, protocol and port, which is really nice to have. You've got all kinds of services, 23, 21, and 20. That's Telnet, FTP. And again, it's FTP and FTP data. So FTP is just control, and FTP-data is data. I always use 2021. And then here's all your different port numbers. If you don't happen to know it, you can do equal, and these are all the items that are allowed. So, and there's allowed or denied, depending on whether you do a permit or deny statement. So you can actually do EQ www if you want to do www, or EQ80. or you could do EQ 443 if you wanted to do HTTPS. So you've got the opportunity to do either a name or a port number, depending on how you want to write it.
Yeah, that's right.
So extended ACL, access list, 100 to 199 if you're using numbered, or again 2000 to 2699. A permit or deny statement, source IP address or source network, source wildcard, and you can even do a source port if you want to. We don't normally do that, but it is possible to do it if you need to be very granular. And then destination wildcard mask, and then the port on the destination. And this is where you have to kind of start wrapping together all of your knowledge from CCNA 1, CCNA 2, because you need to know that web traffic is TCP port 80. FTP is TCP 2021. You know, HTTPS is 443 TCP. You really have to know these things so that you can put those statements in. This statement here that's established, if you happen to run this, it will allow any TCP connection that has completed a three-way handshake back in. So it's going to permit that back in. And that's why they did the 104, because they do the 104 as an outbound and the 103 as an inbound list. And what it will do is the list that's coming from this network, coming into G01, G00, would create a three-way handshake and establish a TCP connection, and then that would be allowed back in. Okay, so basically saying anybody out here that has an established web or HTTPS session is allowed back in this way, which is pretty neat. Really good security measure. The only problem is, if you don't allow UDP, UDP won't work, DNS won't work. So, still apply to interfaces in and out. Again, remember, one per protocol, per direction, per port, or per interface. That's how they like to say it. Here we're looking at denying FTP, denying FTP data, and then placing that, allowing everything else, because extended ACLs do end with an implicit deny. So be aware of that. Named extended ACLs, you just give it a name and it becomes the config X NACL, so extended NACL, named access control list. That's what NACL stands for. You put your statements in, and then you can apply those onto the interfaces. This is the exact same thing we had earlier with numbered lists. So we're allowing TCP traffic to web and HTTPS out, and then any established connections using 103, or in this case surfing, will be allowed back in with the browsing ACL coming back in. Show access list will show you your standard and extended ACL. So you don't have to do anything weird to see different ACLs. Editing standard ACLs, you'll notice that this should have been a 10 instead of 11. You can actually go in and do it by sequence number. So you can go in IP access list extended surfing, which is the name. It takes you in the sub-configuration mode. Do node 10, that would remove the 10 statement, and then replace the 10 statement, and then it fixes it. You could also add a statement in between 10 and 20. You can add 9 of them, actually, 11 through 19. So you can actually put in multiple items. You could just remove the entire list and replace it if you so choose, which is not a big deal in a small ACL, but in an ACL that has a large number of entries, it's easier to do sequence numbers. Any questions on extended ACLs? Because they are pretty simple. All right, guess what? They're IPv6 ACLs. However, we only have named IPv6 ACLs, and they only really function like extended IPv4 ACLs. Now, you also cannot have the same name for an IPv4 and an IPv6 named ACL. Okay. There are no numbered IPv6 ACLs, so be aware of that. One of the things that's a little different about the IPv6 is that with IPv4, you've got the IP access group command to apply the ACL to an interface. IPv6 uses the IPv6 traffic filter command. So a little bit different there, and we'll show you how it's set up. IPv6 ACLs do not use wildcard masks. They're going to use our prefix length to show how much of the IPv6 source or destination should be matched. So it's more like using a wildcard mask, but it's not, not wildcard mask, a subnet mask, because it's just a prefix length. And then you really have to have two, what they call implicit permit statements. And they're actually already there. Every IPv4 has a deny, and IPv6 has that. But by default, because you've got to have what's called neighbor discovery, neighbor advertisements, and neighbor discovery, neighbor solicitation, by default, those two are included as implicit statements in ICMP v6. This is so you can do stateless auto configuration and get IP addresses off of your router, so that you can just place a host on an IPv6 network, and that host can do stateless auto config, and it can get an IP address using neighbor solicitation, neighbor advertisements, or vice versa. If the router needs to know a MAC address, it can do a neighbor solicitation. So those are by default turned on. I mean, that allows it to do the equivalent of ARP. Here's our example topology. You'll notice they use cafe, subnet 10, 11, and 30. And then they use feed, subnet 1, feednet, subnet 2. Okay. And then so on and so forth. So first off, we put our IP addresses in. Okay. So we're doing on R2, colon 2. And we had to do the same thing on R3 and R1. We'd have to actually configure our network. So we put feed colon 1/1/64 all the way across. So we have to have IP addresses up and running. That is something I forgot to actually mention yesterday. It is extremely important that you verify your network works without your access control list before you put your access control list on. Because if you don't, you don't have any idea. Is it an IP address issue? Is it a routing issue? Is it a cabling issue? Make sure you have full connectivity before you put your ACLs on. Then put your ACLs on and test. That way you know it's not an underlying issue with just addressing or something of that nature. Once all that's configured, then you can just configure your ACLs. Now, in this case, it's IPv6 access list name, and then that takes you into the IPv6 access list subconfiguration mode, and then you just do deny permit statements, a source IP with its prefix, a destination with its prefix, and then you can also use any and host just like you do with any other of the IPv4 access control list, and then you also have operator and port numbers. So I can say access list, no R3 LAN access, deny protocol IPv6 from 2001 cafe 30, so this subnet /64 to anybody else. So the source, the prefix to anybody. Then permit everything else. If you don't put this, everything would be denied because except for, funny enough, neighbor solicitation, neighbor advertisements. But otherwise, all other traffic would be stopped. And then you apply it. Okay, and we'll show that in a minute. But now we've seen here, we've gone to R1, we've configured our access list. And now we apply it. So we go to S000 in this case, and they do IPv6 traffic filter, no R3 LAN access in. And that allows nobody to come into that network. Now that is actually, I think that's backwards. I wouldn't have done it that way. Yep, that's backwards. I would have done this as an inbound on gig 00. Okay, because what we're saying in the ACLs, we're saying don't allow anybody, don't allow this network, which is the source, to access any network, which is the destination. So I would have put this, and I believe this is incorrect on this, I would have put it right here. So they're doing, will deny, client A shall have inbound S000, or deny package from. No, that's wrong. Because that would not be true. If you look at our access control list, this is saying deny anything that's source destination. Yeah, they're backwards. Should be right here. Should be gig 00, and that would stop access. If you wanted to stop access to this network, the way they're doing it like this ACL would be different. This ACL would have to say deny IPv6 any 2001 DB8 CAFE :30::/64. So if they want to do it like this, they've got to rewrite the ACL to say that anything coming in to this network, all right, would be blocked. If you want to block anything going out, you would put it as an inbound here. I'll turn this in. Here, go ahead. Anybody got a question?
No.
You agree with me? If you disagree with me, tell me.
I'm still processing it a little bit because it looked like they had it on serial 000 as opposed to one of the gigabit interfaces, and that they were trying to block over on the opposite side where CAFE 30 is. So. Right.
Let me show you. Here's what I'm gonna do. I'm gonna pull this out. So here's the ACL, right?
Mm-hmm.
Now let me pull this up. And what they're trying to say is, they're trying to say if they apply this ACL as an inbound right here, okay, then it would block access from 30. Oh crap! I'm blind as a bat. Shoot me.
Yeah.
I swear. It's Thursday, everybody.
Yep, and see the N is over on this side. So that's why.
I'm a dummy. Yep, sorry. 30's over here. They're right.
Yeah, that's all. Mm-hmm. That's all.
Ignore everything I just said for the last 5 minutes.
No problem.
It's the 30 network over here they're blocking to everybody over here.
Right. Mm-hmm.
Okay. Duh. Now, let me ask you something. Is this breaking our rule for extended ACL?
Because we wanted to be closer to the source, right?
Correct. So they've created this on R1, so they're allowing traffic to cross 2 routers and 2 links and then be dropped. So I would argue, if you're going to follow the rules, and also arguing that you don't have this CAFE 30 going anywhere else. Okay, so in other words, it doesn't need to go anywhere else outside of this. I would have put it as an inbound on R3's gig 01. Now that part I think I am right about. Because you're saying we're going to deny R3 LAN access. Okay. So we're going to create it and say don't allow 30 to anybody else. I'm good with that. But I don't see why you wouldn't put it as an inbound on R3's gig 01 and create it on R3. Because what we're doing now is we're sending traffic that's going all the way across these links.
Right. Yep. No,
and it's being dropped right here.
Yeah. Mm-hmm.
Why not drop it here?
Exactly. Because that's a small network really. That could be a huge network, and then it could take several many hops before it would really get,
Exactly.
Yeah.
So as long as you are not, or you could write it to be very specific too. Let's say that 30 does need to get to other networks out here, but it doesn't need to get to these two. Just do 2 statements that say that 30 can't get to 10 and 30 can't get to 11, and then permit it everything else and make it an inbound on R3. That's what I would do.
Mm-hmm.
And then that way you're saving your router resources and you're saving your bandwidth resources. That's why it confused me, because of the way they wrote it, because it was somewhat backwards. We got it figured out, but it is confusing. So there you go. By the way, I'll go ahead and tell you, if somebody ever tells you they know everything about this stuff, they're lying to you.
That's right.
Run as fast as you can out of their office if anybody ever claims to know everything there is about networking.
Mm-hmm.
Here's an example. We're going to block FTP, and so you'll just see we're going to do deny TCP from anybody to the cafe network, FTP and FTP data, and permit everything else. And then we're going to apply it. So going in and do another access here, restricted access. So just creating that extended ACL. Show interface, well, here's the important thing. Show IPv6 interface, and then it will show you the access lists that are applied, IPv6 access lists that are applied. Same thing, show access list and show, we'll show you IPv6 access list. You also see this is a little weird. The sequence numbers are at the end of IPv6 access list instead of at the beginning, which is a little weird. And you can also see them in the running config if you so choose. This is an inbound access list, and this is why we try to do inbound when we can, because as it comes in an inbound access list, okay, first off, if there's no ACL, it's just permitted, period. There's no, it goes to the route table and destination interface. It's going to go to a route table lookup. If it's an inbound interface and there is an ACL, it's going to go through and find, is there a match? If no, it goes to the second, to the third. If there is any match, obviously it will apply the permit or deny based upon that. If there's no match, it will be denied. If you can set your access control lists up on inbound interfaces, you will notice traffic gets sent to the bit bucket before it ever has to go to a route table lookup. So if you can do that, if you can make it where it's put in the bit bucket before the route table lookup, you're saving router resources.
Mm-hmm.
On an outbound, you'll notice it comes from the route table. So if you've got a packet that's going to be dropped on the other side anyway, you're wasting resources if it goes through the route table and outbound interface lookup and then eventually drops it. Now, will you always be able to do this? Will you always be able to put it as an inbound list? No, you can't. But when possible, if traffic is going to be blocked or dropped on the opposite side, go ahead and have it drop before it has to do that route table lookup.
Mm-hmm.
And people go, well, what does it matter? Well, you know what? It's every little bit that we can save on a network. It's every microsecond, every little bit of processor resources we can save. Did any of you see what happened this past week when there was a BGP I told you about BGP layers being a big problem. The BGP misconfiguration that happened that took down like 3/4 or parts of the entire United States. And what happened was a large ISP accidentally sent the wrong BGP routes out into the internet, saying they were responsible for certain networks, and all that traffic got flooded to them and got black holed. And black hole routes are just basically where traffic goes into a network and is thrown in the bit bucket, and there's no acknowledgement that it was thrown in the bit bucket.
Yeah. And now I've seen that on the small level, working for a service provider where we're on the call, troubleshooting. And that's essentially what had happened.
Oh yeah, I've seen it happen. Most definitely.
It's more a localized area for one particular customer, but they brought down their whole. I'll say a third of their network. I'm gonna tell you that.
Oh yeah. Yeah. And just imagine a small provider that suddenly has 500,000 BGP routes in their network. Yeah. Their routers are going to explode. Mm-hmm. I'm not going to walk through every one of these troubleshooting examples because you can read them, but they are very good for you to read to give you some ideas. Big things that I will tell you about access control lists. Obviously, from my misunderstanding of the ACL that I looked at, one is just not understanding the logic of the ACL.
Right.
The other is not understanding the purpose of the ACL. What are you really trying to do? So you really need to sit down and write out, even just plain language. I'm trying to block this and permit this and this, and at the same time, then you can kind of figure out where it needs to go. Packet Tracer is a wonderful program, but it is a little bit difficult because with ACLs, there are multiple ways of doing things that are both correct. And in fact, there are sometimes ways that they show things in the curriculum that I don't think are the most efficient. Again, that example we just showed. Why let that traffic pass the network just to be dropped? Drop it over on R3 instead of over on R1. But that's some of that real world kind of massaging you have to do with access control lists. It's more of a, I will say this, ACLs have a science behind them in that they are written in very specific ways, but they have an art to them in that the logic behind them is an art form. Now, the iOS does some of that for us now. If we put things in the wrong order, it will try to arrange it for us and massage it. In fact, there's some devices, you know, some of the, used to be the PICs, and I think the SA still does it now, where you can put in a big long ACL and then tell it to calculate the most efficient ACL use, and it will do it for you inside the interface. I still check that though, because anything that's auto-generated I don't trust. But it's, again, something that we will use all the time as we continue our study as access control is. All right, any questions?
No.
Okay, I'm going to stop sharing here, and I'm going to stop the, if I can find it, I'm going to stop the recording.